Opposite angles of a quadrilateral inscribed in a circle are supplementary, right? And what is a quadrilateral that is inscribed? A polygon is inscribed in a circle when every vertex of the polygon is on the circle. So here that quadrilateral is inscribed in a circle means all the four vertices of the quadrilateral are lying on the circle. In that case, their opposite angles are supplementary. We know that two angles are supplementary if their sum, if the total of those two angles is 180 degrees. Alright, okay, now let us have a circle here. We'll draw one circle. Alright, we have a circle, right? This is a circle drawn, and let us draw one quadrilateral with all the four vertices lying on the same circle. Okay, we have here a quadrilateral. Let me fix it up. I got this vertex touching, move it. All right. So all the four vertices are on the circle. Let me see. Yes, it's almost. Okay. Now I'll call this quadrilateral as a, let us call it as A, B, C, D. So ABCD, it is just a quadrilateral. It is not a parallelogram or a square or a rectangle. Just all the four sides you have, and these four vertices are lying on the circle. Hence we say that it is inscribed. Now, what is the speciality of this inscribed quadrilateral? Their opposite angles are supplementary. That is, the measure of angle B plus the measure of angle D is equal to 180 degrees. Similarly, the sum of the measures of this A and C, that is the measure of angle A plus the measure of angle C, is equal to 180 degrees. Similarly, the measure of angle B plus, this is B, plus the measure of angle D is also equal to 180 degrees. We can prove this by making use of this inscribed angle theorem. We have already learned that in this inscribed angle theorem, the measure of this inscribed angle is equal to half of the intercepted arc, right? So let us make use of that. In order to do that, let me join this. This is one radius and the other one I got here. Let me just write down P as the center of the circle. We could have started with that P. Anyway, that's fine. Now, let us take this arc ABC. That arc ABC is the intercepted arc. For which angle this arc I'm taking? Let me use this is the arc ABC, and the angle ADC. We are looking at this angle ADC, right? This angle ADC is the inscribed angle with reference to this intercepted arc. Okay, so we have now the measure of angle ADC, that is inscribed angle, is equal to half of the measure of this arc ABC. Right? Instead of saying AC, the best way is to say ABC, because B is also there and it is precise, where it exactly means that we are talking about this particular arc. Okay. Now, let us take the second arc, the remaining arc, that is ADC. Alright, let me use this here. This arc ADC. That arc ADC is the intercepted arc for this angle ABC, right? For this angle, that is the inscribed angle, right? For that angle ABC, this whole thing is the intercepted arc. Okay, now this measure of angle ABC, the measure of angle ABC is equal to half of the measure of this arc. What is the name of the arc? Angle ADC, the arc, sorry. Okay, so now we have two equations. The first one is saying the measure of this inscribed angle ADC is equal to half of ABC, this yellow arc, and the second equation is saying the measure of this angle ABC is half of this major arc ADC. Alright, now this is the first and that is the second. Now we will add those two equations. On adding, we have the measure of angle ADC plus the measure of angle ABC. I added these two left hand sides is equal to sum of the two right hand sides, with half is a common there. I'll take half out. Half of the measure of this arc ABC plus the measure of arc ADC. Okay. Now, this ADC, this angle ADC, in short, you can just call it as angle D. That is the measure of angle D. ADC is nothing but this D. In the same way, this angle ABC, in short, you can say the measure of angle B. So we have measure of angle D plus the measure of angle B is equal to half of ABC. Where is ABC? This whole piece. Starting from this A, you moved all the way up to this C. And then plus ADC. What is ADC? From this A, you traveled all the way through D and reached back to C. So on the whole, we made one complete circle. Adding this ABC plus ADC together, it is nothing but the whole circle, which is a complete angle of 360 degrees. 360. So what is half of 360? That is 180 degrees. And what is there on my left hand side? It is the measure of angle D plus angle B. Or I can also write it as measure of angle B first, because I am looking for B plus D, plus the measure of angle D is equal to 180 degrees. That is, these two opposite angles are supplementary. we proved that the total is 180 degrees. Similarly, now you know that in any quadrilateral, the sum of the four angles is 360. So out of the four angles, if the two angles total is 180 degrees, so from 360, take away 180, you will get the remaining angle is 180. So I can just say that the measure of angle A, this measure of angle A, plus the measure of angle C is equal to 180 degrees, or you can do it by the same process by connecting the other radii, and you can do it, or directly you can show it in this way. It's very simple, right? In this quadrilateral, all the four vertices are lying on the circle, so it is inscribed inside a circle and its opposite angles are supplementary. Now let us work out these two problems. Here we have a circle and two angles are given to us, and our task is to find the remaining two angles. What is this third and fourth angle, I can say. Now you already know that this is a circle and two angles are given. If this is 70 degrees, the angle opposite to that, you know that those two opposite angles are supplementary, hence its measure must be how much? From that subtotal is 180 degrees because of the supplementary angles. Take away 70, 180 minus 70 is how much? 110 degrees. Hence this third angle is 110 degrees, and to get this fourth angle, I have to look at these two opposite angles. So from 180 degrees, take away 115 degrees to give you 65. So the fourth angle is 65 degrees. It is as simple as that, right? So we can find, given one angle, the other one right across the opposite angle can be obtained. But in the second problem, you have x's also, x plus 10, x plus 20, and this x plus 40 and x plus 30. First find the value of x. You are asked to find what is the value of x and then what is the measure of each of these four angles. Okay. Now you know that this quadrilateral is inscribed in the circle because of all the four vertices are lying on the same circle. Hence the sum of these opposite angles is equal to 180 degrees. X plus 10 plus x plus 40 must be equal to 180. Alright, opposite angles are supplementary, that is x plus 10 plus x plus 40 is equal to 180. Now these two are x's, I can add. We are just solving for the value of x. 1x plus 1x is 2x, and this is 10 plus 40 gives you 50. That 50 degrees, that is 180 degrees here. Now solve for x by using the same old regular process. Subtract 50 degrees on both sides to give you, that's cancelled off, 2x is equal to 180 minus 50 is 130 degrees, and divide both sides by 2 to give x is equal to, this of course cancelled, 130 divided 2 will be 65 degrees. So this first angle is how much? X is 65. 65 plus 10 is 75 degrees. The first angle is 75 degrees. And this third angle, or the angle opposite to this, is x plus 40. And you know your x is 65 plus 40 is 105. And check it out. 75 plus 105 is nothing but 180. They are supplementary angles. That's what we had here. Similarly, let us first substitute x equal to 65 and see if this condition also satisfied. 65 plus 20 is 85, right? 65 plus 20, and that is 65 plus 30. 65 plus 30 is how much? 95. This is 95. 85 plus 95. 85 plus 95 is again 180. These two are also supplementary. Hence all the four angles are 75 degrees, 85 degrees, 105 degrees and 95 degrees. Those are the four angles. These are just two examples. Okay. Thank you. Thanks for watching.